All right, it looks like it's 11:05. So welcome everyone to the water quality session. Today we have Abby Tyrna. She's the water resources agent for Ooh, my phone's Sarasota IFAS. And today she'll be educating us on the drinking water cycle in Sarasota County. Dave Tomasko is the executive director of the Sarasota Bay Estuary program and has over 30 years of experience in water quality assessments. Today, he'll give us an overview of the water quality history, present, and future of Sarasota Bay. And finally, Jack Mackay is a senior at Eckerd College. He's majoring in marine science, and it sounds like he's going to do his graduate studies in marine science. He'll speak today about his research on artificial reefs and using filter feeders to improve water quality. So each one of the presenters, they'll go in that order. Abby, Dave, Jack will be running their own presentations. So take it away, Abby.
Thank you. All right, I'm going to share my screen. Thank you so much for inviting me to be here today. I am going to present on our tap water. I was asked to speak about our drinking water, which can be referred to as potable water, tap water. So I'm going to talk about it from the tap to the bays and in between. So have you ever stopped to think where your water comes from and where it goes when you're done with it? Like really, have you ever stopped for a minute to think, when I turn on this tap, how do I get this miraculous source of water? Well, most people I find, and so have researchers, that most people can't even name the freshwater source that their tap water comes from. Can you? Let's go ahead and explore. So today we're going to explore where our tap water comes from, where it goes when we're done with it. Is there enough for the future? And how much should I save? I'm going to refer to our region a lot in the term our region, which if you look at the upper right-hand corner, you can see that the Southern Planning Region is actually what I'm referring to, and it's made up of Manatee County, Sarasota County, DeSoto County, and part of Charlotte County. So first, where does our tap water come from? Easily put, our tap water comes from ground and surface water sources. And so most of the cities in our region, who only need around 2 to 6 million gallons a day, can heavily rely on our groundwater sources. Most of it's brackish and needs special treatment. The bigger municipalities in our region, like Manatee County and Sarasota County and the city of Northport, must rely on surface water sources, mostly. But there's a mixture of both. Specifically, to treat our 103 million gallons a day that's used in our region, we use about 1/3 from the intermediate and the upper Floridan aquifers, and 2/3 from these surface water sources, Peace River, Manatee River, Braden River, and the Mahacahatchee Creek. So if someone asks you what is the natural body of water where you get your drinking water, hopefully now you can name one of these sources and you'll be correct. The water moves from these sources to the 780,000 customers via 5,000 miles of pipe, 24 storage tanks, 7 treatment plants, and 27 pump stations. That's how the water gets to our tap. Lots of effort there. So let's take a look at one of these water treatment plants. Let's take a look at the biggest player in the region, which is known as the Peace River Minnesota Regional Water Supply Authority. So here's an aerial image of the Peace River Minnesota Regional Water Supply Authority. And as you can see, they have a huge reservoir, a smaller reservoir, and then they have a lot of aquifer storage and recovery, or ASR, wells that allow them to store the water below the ground and then pull it back out. And that water is treated to drinking water standards, pulled back out, and treated again. So this major player in our region has a 50-year permit that was granted in 2019 to pull 258 million gallons a day from the Peace River. And that, I don't have time to go into when they can pull it, but the river has to be at a certain stage. And they have a treatment capacity right now of 51 million gallons a day, although they're only treating around 38 million gallons a day. And they have enough storage for 245 days via 21.5 billion gallons. That's currently. All right, so we know where the water comes from, and we know where it stops along the way to get treated, but where does it go? So for the average Florida home, half of the water goes toward outdoor irrigation. So that means about 50% is used to water our landscapes. And what we know from research is about 50% of that is wasted. And it's wasted because of inefficient irrigation systems. Whether you see there on the lower left, sprinklers watering the street, or in the middle, a sprinkler head that's just broken and not doing much of anything at all. And then on the right, the sprinkler system doing a lot of watering of the driveway. When the sprinklers water these hard surfaces, they collect contaminants moving down gradient, which goes into the stormwater system and eventually ends up in the bay. The other half of that water that's treated and goes to your home is wasted. It goes to the wastewater treatment facility after we flush our toilets, turn off our sinks, use our laundries. And in Sarasota County, this wastewater travels via 1,300 miles of pipes, goes to 3 water reclamation facilities via 723 lift stations. And so there's actually a lot of work put in place for the 84,000 customers in Sarasota County to take away that water once you use it. And all that water that we use, so half of it outside, half of it in our homes, when the half of it in our homes goes to the wastewater treatment facility, about half of that, or 57%, is actually reused as reclaimed. So it's treated and then sent back out to customers via 103 miles of pipes, 5 pump stations, and 377.6 million gallons of storage to go to these 121 reclaimed water customers. And so where does that reclaimed water go? Well, it goes back out to customers. So most of it's used on farms, golf courses, and again, it can be sent to individuals so that they can irrigate their lawns. And even with reclaimed water, some of this irrigation is inefficient and can end up on those hard spaces and move through the stormwater system and into the bay. Is there enough water for our future? 44 million gallons a day. That is the number I want you to remember, because that's the additional water that's needed by 2040, according to the Southwest Florida Water Management District. But you might be thinking, well, I mean, is there much I can do about that? Like, which sector uses the most water? So out of these sectors, the public supply, commercial, landscape and recreation, and agriculture, which one do you think uses the most water? And I don't expect you to answer, because even if you did verbally, I couldn't hear you. So I'm just going to go ahead and tell you that that big chunk of pie, that 53%, is actually public supply. That's you and me. That's the water we get. The smaller but also bigger slice of pie is what agriculture gets, mostly in citrus in our region. And then the other is split 5% among commercial, other various uses, and landscape and recreation. So we are the biggest chunk of the pie, so we can do something. So the question is then, how much should we be doing? How much should we save? Well, Southwest Florida Water Management District wants us to save 10%. And you can save 10% by taking some of our online courses and learning more ways to do it. You can sign up for a free irrigation evaluation, which we can help make your irrigation more efficient and save that 50% that's put outside. And then you can go to the Southwest Florida Water Management District's water calculator to look at your water use and pledge to save 10%. We can save the drops, save money, and protect the bay. But what will saving 10% actually get us if we all do it? It'll get us 44 million gallons a day. Thank you.
Thank you, Abby. Dave's up next. There you go.
All right, so hopefully that's working.
It is.
Perfect. All right, so clumsy title, so let's just move on. But we're going to talk about the health of the bay and what we can do to protect and restore it. Healthy bay is important to our quality of life in this area. Sarasota Bay Estuary Program is one of 28 throughout the country. We have an awful lot in common with every other estuary program in terms of like estuary being important for fish and crabs and shrimp. We have, green sea turtles, manatees, coastal resilience. But one of the other things is our quality of life has an awful lot to do with how people recreate in our bay, different than, say, Narragansett Bay and Puget Sound. People like to get out of the water in their boat, and they want to stand around in waist-deep water and see their feet. You don't want to have rafts of mackerels you're wrapping around themselves, their kids, their grandkids, that sort of thing. And so one of our goals in the Sarasota Bay Estuary Program is to maximize water clarity to the greatest extent that is appropriate for that location. A healthy bay is important to our economy. There's 20,000 jobs that are associated with bay-related activities. And also there's a property value uplift associated with proximity to the bay that is worth about $3 billion, which is a big part of like our local government's ability to pay for things like water supply and wastewater treatment plants. But one of the other things is that it's important for our Florida wildlife heritage. And we're going to talk about seagrasses and water clarity and stuff like that. And now I realize not everyone knows what seagrass is. So the picture on the left is a manatee floating around in the water with its main food source, which is seagrass. They eat about 100, 200 pounds of seagrass a day. These plants grow in the bottom of the water, at the bottom of Sarasota Bay, and they need enough light, which means they need water clarity to be good enough for them to be able to survive. The first 6 months of the year 2021 was already the worst year on record in terms of manatee deaths. So far this year, we've lost more than 10% of our manatee population. It would be as if the United States lost 33 million Americans. Over on the Indian River Lagoon, which is the epicenter of the loss, estimates are around 20%. The picture on the right-hand side shows manatees over on the East Coast right now. And if you look at them, they look really not the same. And that's because these are manatees that are starving to death. The reason why they starve to death is because their food starts to go away. Picture on the left is from the Indian River Lagoon. This is what Sarasota Bay does not want to look like. Well, Indian River Lagoon doesn't want to look like this either, but that's where they are. Water quality problems have resulted in a decrease in seagrass acreage of 60%. The remaining 40% is so sparse that their overall food supply is down 90, 95%. That's how you starve manatees. The blue line represents how far offshore the seagrass meadows grow, their offshore edge, and that's become shallower and shallower, which makes the manatees feeding on existing grass beds more exposed to colder temperature and colder air. So if we don't want that to happen in Sarasota Bay, we have to know what we have to manage for. Sarasota Bay is sensitive to nitrogen levels. It's not the only thing we have to work on, but it's probably the primary thing right now. This graphic shows a cartoon like going from left to right. What happens as you increase nutrient loads? On the far left is something, like maybe the dry tortugas or the Exuma Islands in the Bahamas, something that's not really appropriate for Sarasota Bay to be, and it won't ever be like that. On the far right-hand side with increased nutrient loads might be the Indian River Lagoon right now. And so everything in here, except for the fish, is part of a report card that we have for coming up with a more holistic way to describe what is the health of the bay. So our report card is based on 4 separate metrics, if you would. Chlorophyll A is an indicator of how green the water is, which is an indicator of how much algae is floating around in the water column. Nitrogen is a nutrient that can make the water greener or can make more macroalgae, which is the big tumbleweed kind of stuff that floats around. And then seagrass is something that we measure as well as the overall indicator of system health. And when we put our report card together, we're limited by the amount of data that we've got. And we've got data on all 4 of those that goes back to 2006, not before that. And if we look at the years 2006 to 2012, this was a healthier bay back then. We had an overall 28% increase in seagrass coverage. That doesn't happen unless you have a healthy bay. We had lower levels of nitrogen. We had no bay segment impaired for chlorophyll. Now we have plenty of bay segments impaired for chlorophyll, too much phytoplankton. And where we have macroalgae data, we did not find as much as we have recently. So we report on the health of the bay in different bay segments because there's not just one bay. There's different things happening in different parts of the bay. And I'm going to show you the report card next. And the scores are color-coded. If you want more information, go to sarasotobay.org, and we have the details of how it was done. But I'm going to show the results as color-coded. Green and blue represent higher scores, represent pretty good conditions. Yellow represents caution, like something's going wrong. And red represents something has gone wrong. Stop what you're doing and figure out how to make this system better. So if we look at our report card for the bay, we can see that 2006 to 2012, this was a healthier bay across all of the bay. It wasn't just one part of the bay. So we had healthy conditions across all of the bay. Yeah, Blackburn Bay in 2011, but whatever, that's 1 year. If we look in Tomasko Bay, it continues to be a healthy bay. So Tomasko Bay continues to be a healthy bay. Monitor it, make sure it doesn't slip. The upper part of the bay, from say Siesta Key Drive up to Manatee Avenue, that part of the bay was doing pretty good, blues and greens, but then it dips into the yellow range in 2017 and 2018. And what we think happened is we had three things happen in a very short period of time. 2016, 2017 was a strong red tide. 2017 was Hurricane Irma. 2018 to 2019 was an even stronger red tide than the earlier one. The combination of those three things happening over a short period of time resulted in water clarity just kind of nosediving for a while, particularly in 2018. And we think that was responsible for shifting into yellow and a seagrass loss of about 2,000 acres. The good thing is that's historically been a healthy part of the bay, and we're already back up into the green. The water clarity is already back. It's about 8-foot visibility now. The seagrass has not come back yet. But that phenomenon of the red tide, you can't say that that's the problem in Roberts Bay, Little Sarasota, or Blackburn Bay, because they were yellow back in 2013. And the reasons for their problems are not red tide. There are things on top of it. But even within those three, look at the difference between Roberts Bay recovering back into the green and Little Sarasota Bay and Blackburn Bay not quite recovering. So we have actually four different phenomena happening here. Tomasko Bay is different than the Upper Bay, is different than Roberts Bay, is different than the combined Little Sarasota Bay and Blackburn Bay. So we need 5 different approaches to managing this bay. Some of them need protection, some of them need restoration. Our overall indicator of the health of bay seagrass coverage bay-wide is 22% down from its peak in 2016. So that's not as bad as the Indian River Lagoon, but it's a third as bad as the Indian River Lagoon. So it's not quite panic stage yet, but we don't want this to continue to go down. We want to level off, and we want it to get on that upward increase. And some parts of the bay are showing that already. But this isn't something that we want to see continue. We aren't as healthy as we were 10, 15 years ago. So how do we get healthier? Well, if we look at those 2 time periods, the healthier bay and more recent years, our pollutant loading model says that our nutrient loads are about 20% higher now than they used to be. Well, if you want your water quality to come back, get your nutrient loads down. And that's what we're planning on pursuing over the next year to formalize this plan. So we're looking for about 12 tons of the most particularly damaging form of nitrogen, which is dissolved inorganic nitrogen. So almost home now. Can we reduce inorganic nitrogen loads by 12 tons? The difference between that reference period and where we are now. And we think we can, because reclaimed water that Abbey talked about, that can be a perfect way to reduce our water use, but some people will overwater and they will fertilize on top of it. And sometimes the nutrient content of reclaimed water can be high enough that you don't need to actually produce any more fertilizer to get to where you need to be. So if we look at the combination of reclaimed water, spills, and septic tanks, it's way more than 12 tons, which means the controllable or potentially controllable nutrient loads are greater than the load reduction target, which means we should be able to get this done. And one of the neat things is Sarasota County, Manatee County, City of Sarasota, Bradenton, Longboat Key, they've already come up with about $600 million worth of projects to reduce nutrient loads by acting on wastewater and stormwater infrastructure. And what we're trying to figure out is, will that be enough to get us back to where we want to be? And will that be enough to hold the line as we move through the next couple of decades? So last 2 slides. Is it realistic to be optimistic with all that needs to be done? This is a plot of nitrogen concentrations in the open part of the bay. The last couple of years are in the red. The reference period is in the blue. You can see that, there's quite a bit difference. The nutrient concentrations are quite a bit higher now than they were in that reference period. So is it realistic to expect we can actually move backwards in time? And I think the answer is yeah, because look what we've already done. This bay is not as clean as it was a couple of years ago, but it's cleaner than it was a couple of decades ago. That's the reality of Sarasota Bay. So when we talk about Sarasota Bay's future, it's not restoration, it's re-restoration. We need to do again what we've already done. And if there's any questions, we're a pretty formal group. Best way to contact me is dave@sarasotobay.org.
Thanks, Dave. Next up is Jack. He's going to share his screen and talk about artificial reefs.
Hang on. All right. Is everyone seeing that?
We are.
All right, great. All right, so today I'm going to be talking about the collaborative research between Eckerd College and the Center of Anna Maria Island on artificial reefs and whether or not they can help to restore coastal habitats here in Florida. So in a natural coastline here in southern Florida, we already sort of have natural checks to water quality. This primarily comes in the form of mangroves and mangrove habitat. The benefit of mangroves with respect to this presentation is sort of twofold. Mangroves as plants use up excess nutrients, both from the water column and from the substrate that they're rooted in. This sort of outcompetes phytoplankton and other blooming organisms, reducing the amount of resources available to them and reducing the risk of a blooming event. They also provide plenty of surface area for what are called sessile filter feeding invertebrates. These are organisms that sort of float around in the water column as larvae and eventually settle down on a flat surface and stay there permanently. And they're pulling water in through them and pulling out phytoplankton, bacteria, other particulates. So they're sort of direct predators of these phytoplankton like red tide and other organisms that tend to bloom. Here in the image in the top right, you can clearly see some oysters all over the mangrove roots, and oysters are sort of the poster child for filter feeding invertebrates, but they aren't the only organism that does this. And just to sort of shed some spotlight on a couple, we've just got some bushy bryozoan on the left. This is a small colonial organism that you'll find commonly on docks, on mangroves, things like that. And they're a small filter feeding organism, but just something of note, not only are they useful for ecological services, but this species in particular has actually been used to derive certain compounds that made up some of the first treatments for certain cancers. So just highlighting how these organisms have benefits just not only for the ecosystem and coastal habitats, but also for us as humans. On the right is some ribbed mussels, which is another bivalve mollusk like oysters, which operate very similarly. They filter feed and prey on phytoplankton, and these two plus oysters are just a small sample of these invertebrates that colonize these habitats. I could spend this whole presentation just talking about them, but I won't. Unfortunately, a lot of the coastline here in Florida doesn't look like this anymore. We do have some mangroves, but they're not nearly as prevalent. A lot of our coastlines tend to look like this, especially in residential canals, boat harbors, things like that. We have these flat seawalls, these flat, metal or concrete surfaces, which just provide far less surface area. They usually have a small covering of like oysters and some invertebrates, but the sheer surface area is nothing compared to what is typically provided by mangroves. And because there are no mangroves, there's higher nutrient availability. And because there are fewer filter feeders, there's fewer organisms to keep any potential blooms in check. So this leads to a higher risk of harmful blooms, including red tide in these areas. So the question here is just what can we as citizens do to sort of mediate this issue and try and reduce the risk of these events. So one of the more recent ideas that people have had are artificial mini reefs. These can take a myriad of different forms. They come in like as many different structures and types as you can imagine. But for the purposes of our research, we focused on these multi-tiered structures made of PVC and corrugated polypropylene plastic. This polypropylene especially was selected due to its low tendency to produce microplastics, little to no microplastics actually. So trying to keep the environmental impact of these structures in mind. But basically these multi-tiered structures provide additional surface area for filter feeding organisms and other organisms for that matter to colonize beyond just the seawall. And here in these images, you can see that colonization can actually take place very rapidly. This image in the top right is a reef just 1 month after being placed in the water. And I know it's a little hard to see in the image, but these sort of bushy pink structures up here, those are actually those bushy bryozoans I mentioned previously. We also have here these little sort of spikes almost coming up off the reef. Those are small polychaete worms that can either feed on the detritus on the reef, like the biotic material, or they'll even filter feed, depending on the species. And here on the bottom is an example of what a reef will typically look like 2 or so years into its maturity. And these large growths hanging down, those are actually what are called tunicates or sea squirts, which are just another really efficient filter feeding organism that would typically colonize a mangrove, but in this instance, colonize mini reefs. So the question here is really, does it work? Is it worth putting these structures in place? How effective are they? That sort of thing. And that's the question that we're attempting to answer with our research. Unfortunately, right now, our data only goes as far back as March of this year. And we kind of feel as though it's too soon to make any sort of substantial solidified claims on just how effective they are, where they should be placed, things like that. But just observationally, looking through our data sets and just looking for maybe potential patterns, we have noticed that canals with reefs do seem to have lower chlorophyll. Chlorophyll is our proxy measurement for phytoplankton in the water column. Phytoplankton has chlorophyll in it. That's the pigment that allows it to photosynthesize and produce its own food. So if we take a water sample from a canal and put it into what's called a fluorometer, that fluorometer passes a wavelength of light through the water sample, causing the chlorophyll to sort of fluoresce a little bit and glow just a little bit. And the fluorometer will take up that amount of fluorescence and give us a number of the amount of chlorophyll in that water sample. So we can use this measurement to compare the amount of phytoplankton in different canals. We've also noticed that there tends to be a higher diversity as well as a higher abundance of larger, maybe vertebrate species, striped mullet, tarpon, species like spotted eagle rays and barracuda, species that tend to be more economically important, be it for food or for just angling and fishing. We tend to see more of them in canals that have these reefs. And then just another thing I'd like to highlight is that research into alternate strategies, particularly alternate materials for reefs, is ongoing. For instance, our research group is really interested in this species of terrestrial grass as a potential reef structure. This grass is native to the Caribbean and it can be found in Cuba. People in Cuba will often weave nets and aquatic corrals that they place into the water for collecting fish for food. And these structures will last for years and years even in marine environments. And what researchers have noticed in Cuba is that invertebrates will actually colonize these nets, similarly to our artificial reefs. So the thought is maybe we could create similar structures out of this grass species for reefs. The additional benefit being is that this grass is actually invasive here in Florida. It can be found throughout terrestrial environments as an invasive species. So if we were to create a reef that could use this as a material, there would be a potential economic drive to actually remove this species that would have a direct benefit for other environments as well. So benefiting both terrestrial and marine environments. We have not actually done testing with this. We are looking to do so fairly soon though. And then just a final aspect of our research that we're pretty proud of is community outreach. We'll actually take citizen volunteers, both from Anna Maria, which is the island where we conduct our research, and beyond, from places like Venice, other areas within the state, and we'll take them on board with us onto our research vessel and instruct them on proper data collection techniques and how to actually use the instruments and equipment that we use to collect our own data. That way we sort of create and foster this network of people who are learning about the importance of coastal habitats and who are even collecting their own data so that we have more data to pool together basically so that we can all collaborate to get a more accurate understanding of what's actually going on. We've also created instructional videos with the help of locals. Here in this image, this gentleman here joined us for a few days and recorded us doing different things. Here in this picture, me and one of my colleagues are talking about the different invertebrates that you can typically find on a reef. We've also published videos on how to use the different probes that we use, like the YSI probe and the fluorometer that I mentioned previously, so that maybe if someone is out of state or can't quite make it to join us for whatever reason, they can still access these videos and get an idea of how we're collecting our data so that they can sort of replicate what we're doing so that all of our data can be easily compared. And if any of this sort of stuff interests you, please definitely, reach out to us. Come join us for a day. We'd love to have you. And if you have any questions regarding that or just even the research, here's our contact information. If you have any research-based questions, maybe reach out to me. My email is jamackay@eckerd.edu. And if you'd like to schedule a day to come out with us, I'd reach out to Jim McDaniel. He's the Director of Development at the Center of Anna Maria Island. You can reach him either at his email, jim@centerami.org, or through his extension at the center. You can just call the center's phone number, 941-778-1908, extension 201.
All right, thank you, Jack. We are exactly on time, which is wonderful. I forgot to introduce myself. I'm Amber Whittle. I'm the Executive Director of Southface Sarasota at the Florida House. I'd also like to mention that this was Jack's first big scientific presentation, and so he got 101 of us, and you did an excellent job, Jack, so keep going.
Thank you.
So the first questions, I will this is going to be for you, Abby. There's a lot of questions about septic systems, especially the Philippi Creek septic to sewer replacement and where that is at, and how new septic is still being permitted right on estuary boundaries.
Yeah, so thanks for the question. I'm not an authority on that, and thanks to Brian Figgin for posting a link in the chat. The link is to the Sarasota County webpage, and actually, if you go to Sarasota County's government's webpage and just type in the search water quality, you'll go to a water quality page that has links to a bunch of questions, whether it's about septic or really anything to do with water quality monitoring, etc. So that's a one-stop shop for answering hopefully all the questions that you have. So again, you go to Sarasota County government's website and just put in the search water quality, and you'll be able to go to the water quality webpage to get those questions answered. I do know that from sitting in meetings that there is some initiative to really look to prioritize replacements in the future so that there's a certain setback from a water body, specifically our like class 3 water bodies or those regulated water bodies under the Clean Water Act. And the Department of Health has a lot to do with, the septic tank program. And so also doing some sort of reconfiguration of who gets to be in charge of such programs and how that money is going to come in. We are not in a BMAP or a Basin Management Action Plan area. And so because of that, we don't get some of the funding that other municipalities get when it comes to septic replacement.
All right. Thank you, Abby. The next question is for Jack. Are you only looking at reefs for nutrient reduction in the bay? And is anybody exploring reefs in the Gulf for erosion protection?
So we're not only looking at reefs in terms of water quality and parameters, we're also seeking to understand how these reefs can benefit the biodiversity and ecosystems directly. Recently, we've even begun looking at reefs in different areas. So comparing reefs that were placed on a coastline with seawall versus reefs placed in a coastline with mangroves, because some of these canals we study actually do have some mangroves. And what we are noticing even right off the bat, even within a couple of weeks of colonization, is that reefs within mangroves tend to have a more diverse ecosystem than reefs on a seawall. But regarding your question about erosion, I'm not entirely sure actually. Where we're conducting our study, water flow and erosion isn't really an issue because these residential canals are deep within a small bay in Tampa Bay. So it's a pretty sheltered environment with not a lot of erosion issues. But that would be a really interesting thing to look into about whether or not artificial reefs benefit erosion problems in a more high energy environment. Yeah, I wish I had a better answer for you on that one though.
Not that you know. All right, Dave, I've got one for you. Is other than red tide, what has changed in the last 5 years that has caused this decline in seagrass cover?
Yeah, so it depends on where you are. As Amber is talking about, the red tide, we believe, was the reason for the large loss, 2,000 acres. But we lost seagrass in the lower bay before that. So from about 1988 to 2014, we had a 30% increase in seagrass in the lower bay. So from Siesta Key Drive down to Venice Inlet. And then from 2014 to 2018, We lost all of that. We're back to where we were 30 years ago. So that loss precedes the loss in the upper part. The reason for that, we believe, is just the typical what we'd call cultural eutrophication. Overflowing wastewater treatment plants, elevated levels of stormwater, like we say, over-fertilization of the major land use that we have is residential. So we think it's more like the typical cultural eutrophication, which means human nutrient enrichment. And we are starting to see some signs of improvement. The water quality in Roberts Bay looks like it's getting better, because it looks like one of the main problems we had was overflows from the Bee Ridge wastewater treatment plant. That was about 750 million gallons of overflows that occurred over a 5-year period. We haven't really had much of an overflow at all over the last, say, year and a half or even a little bit longer. So it looks like acting upon the sources of nutrient loads shows some sign of response in Roberts Bay already. And that would match up with what we saw historically, which is our seagrass recovered about 50% from the worst conditions, which were in the late 1970s, early 1980s. So we've actually got a restored bay that we let slip away from us because our population has increased about 70% since those big nutrient load reductions. So we did an awful lot in the late 80s, early 90s, and then our population grew 70%. And we just didn't accommodate the population growth, and the bay just started to get worse. And so we have to get another load reduction, and then we need to hold the line unless we want to be right back here in another 10, 20 years.
All right, thanks, Dave. So Abby, I'm going to ask you a planted question, and I'm saying it's planted so everyone doesn't think I'm crazy. If we're having all these water consumption problems in the future in Florida, should we all just start drinking bottled water?
The answer is no, absolutely not. So if you think about all the things that I just talked about how the water gets to our house and all the checks and balances, which I didn't even get to speak about, but there's a lot of checks and balances in place. There's a lot of regulation. There's double regulation. There's regulation of the water at its source before it even is pumped. And then there's regulation of the water after it's pumped and cleaned at the water treatment facility. And so there's regulations along the way about when it sits in pipes and stuff like that. There's a ton of regulations to keep that water meeting and exceeding Safe Drinking Water Act standards. That same thing does not occur for bottled water. And we know from research that when you consume bottled water as your major water consumption, you are actually getting an order of magnitude more tiny plastics in your body, which scientists don't know how that affects you, than if you're consuming tap water. So definitely consume tap water. And then finally, I'd just like to say that the reason why I wanted you guys to know where your tap water comes from, because there's other research to show that once you know where it comes from, and you can name that water body, that you're actually more likely to care about that water body than if you just pull a bottle out of the refrigerator and have no idea where it comes from. You don't care about the energy use that it took to get there and all that went into making that bottle. And you could just simply get it right from your tap.
All right, thank you, Abby. We had to have our ad for non-bottled water. So Jack, I'm going to ask you a question from Jay Lavaroni. Any idea as to how many reefs would have to be installed to make a significant impact on reducing nitrogen in the bay? Without removing the reefs, are nutrients being removed or just biotransferred?
So regarding the number of reefs, we don't really have much in the way of data regarding like the amount necessary. But what I can say is that in the reefs that I meant, in the canals that I mentioned in my presentation, where we have noticed certain trends with lower chlorophyll, these canals tend to have at least like 8 to 12 reefs or so. We haven't analyzed these canals for like, reef per, unit of water ratios or anything like that. But it seems like in these residential canals, 8 to 12 is a good number to sort of aim for. And then regarding like nitrogen and other nutrients, whether or not, removing the reefs is necessary versus, just leaving them alone, or what's happening with them. These nutrients are like, as the filter feeding organisms take them in, they're using that to grow and become larger, basically. And then your larger vertebrates, your fish, things like that, your predators like crabs, even that we see, they're consuming them. And it's just, instead of the nutrients sitting around in the water waiting to be used by algal blooms, they're sort of being put into a nutrient sink, so to speak, where all of these organisms are sort of sequestering it in their body and making it into a form that phytoplankton can't use, essentially.
All right, Thank you. Okay, we've got one more question. Dave, this is not your area of expertise, but I'm going to ask you. So water wars, do you think we're going to end up in regional water wars because most of the water we're using is not from here?
Well, it's one, we did have water wars. The biggest one was up in the Tampa Bay area, where the vast majority of water was groundwater withdrawals from northern Hillsborough County and southern Pasco County. It's one of the reasons why you now have the Peace River Manitoba Regional Water Supply Authority and also Tampa Bay Water, is so that water would be viewed. In the state of Florida, water is viewed as a shared public resource, and that's not the case in like, say, Texas, for example. So the idea of these regional water supply authorities is that they are to share the cost of developing water supplies and share the cost of designing the best appropriate strategy for delivering water to people. And so I think water wars isn't really what's going to happen. The state of Florida is set up such a way that you don't really solve problems with litigation the way we used to. But it doesn't mean you're going to be able to meet your public supply. I do think one of the main things that we need to talk about is what Abbey hit on. It makes very little sense to use drinking water for watering your lawn. It makes a lot of sense to use reclaimed water for public water supply, but you can make your water supply last longer if you don't overwater, regardless of what it is. And if you do use reclaimed water, be careful with it. You probably, Abbey can get you to the websites. You probably might not need to fertilize if you use reclaimed water. And so just be real careful, reach out to the University of Florida for it, but I don't think you're gonna have water wars. The state of Florida has lived through that, and they've developed a system to kind of try to avoid that.
All right. Well, thank you very much to our panelists.